Well, I want to discuss the very basic of probability conditional or conditional probabilities, which is a part of probability theory. Well, let's go to do the very basic. Let's assume that we have two events. This event, let's say this is my event, and this event that has two possible outcomes, A or B. The probability of A is equal to 50%. Probability of B is equal to 50%. If I have an event which has only one possible outcome, let's say event C, well, because it only has one possible outcome, probability of C is equal to 100%. That's why here, when my probability is divided by two possible outcomes, so probability of A plus probability of B, that is equal to 50% plus 50%, which is equal to 100%, which is equal to 1. Okay? Probability of A not happen, well, that is equal to 1 minus 1/2, or 100% minus 50%. Probability of B not happen, that is equal to 1 minus 1/2, which is equal to 1/2, which is equal to 1/2, which is equal to 50%, and which is equal to 50%. But what happened when we have a conditional probability? Let's say conditional probability means that what's the probability that A happen when B has happened? In other words, B has to happen first to see what's the probability that A will happen. Well, if we do this Venn diagram, so it says that probability of A given B. So this is B, and let's say this is A. Probability of B is this part. And this has to happen first. If B happen, what's the probability that A will happen? Well, that is this part, because that's the part of intersection of A with B. So this probability of A given B, it's equal to the probability of the intersection of A intersection with B over probability of B. That is this intersection. This is the intersection. But the probability of the event, the probability of A given B, is equal to this intersection over B. And how do we can prove that? Well, we can prove that, for example, if we, let's say, let's go to delete this. Let's say this. Probability of B, it's equal to the probability of B intersection with B over probability of B. This is something like this. This is B, this is the event B, and the intersection with B is the same because it's the same. So this is equal to probability of B over probability of B, which is equal to 100%, because it is. When we have another event here, and let's say that, let's say, well, I'm gonna delete this. Now let's say that we have probability of A given B that is equal to probability of A intersection with B over probability of B. Because this is the domain that has to happen first, so that this probability will exist. So this will be like this. I have B and I have A. Probability of B is this. Probability of A given B is only this part, which is less than 1, that 100%, unless A is equal to B. I'm putting this because I will discuss later on an event of probabilities for election systems and also for influence behavior. When we have a community, when we have one person here, which is C1, but that person eventually is influenced by this community, but C2, C3, C4, C5, until Cn. So in this specific case, we will discuss how this community of C influence one individual. We can call that emotional contagious, behavioral economics, or consensus effect. This is all part of conditional probabilities and probability theory. But this is the very, very basic of how an event can happen and how we can measure the probability of the outcome based on new information or additional information. Well, this is very basic, but it will be very useful for predictive analytics and for predictive intelligence.